Section 7 of this preview chapter here is on rational expressions. And when we talk about rational expressions, the first thing we want to think about is that they're really just fractions. And a fractional expression is simply the quotient of two algebraic expressions. So a rational expression is a fractional expression, so it's going to be a fraction, where the numerator and the denominator are both polynomials. So they're both going to have that form that we talked about in previous sections. Some examples of these would be 2x over x minus 1. Another example, x over x squared plus 1. Or you can see the third example there, x cubed minus x over x squared minus 5x plus 6. So each one of those is a rational expression because not only is because both the numerator and the denominators are polynomials. The domain of any set is the set of real numbers, the domain of any function is the set of real numbers that a variable is permitted to be. So in other words, when we put in these numbers, we can't get anything that's undefined. We also can't, well, that's the big thing, we can't get anything that's undefined. So when we look at a rational expression for part A here, finding the domain, we have 2x plus 4 over x minus 3. Well, when you look at the top, the numerator, this can really be anything. I can put in any number for x, and I can multiply it by 2, and I can add 4, and that doesn't ever create any problems. But on the in the denominator, what happens here is we have to be sure that this denominator, x minus 3 in this case, does not equal 0. Because if x minus 3 equals 0, that makes the function undefined. So we know that x minus 3 cannot be 0, so x, when we add 3 to both sides, x cannot be 3. So when we write this out in set notation, we just write out x, all the x's, the set of x's, such that x does not equal 3. And that gives us our domain. It's anything except for 3. For part B, you can see we have a polynomial there, 2x squared plus 3x minus 1. The nice thing about polynomials is the domain is always all real numbers. So our symbol for all real numbers is just an R there that has a double bar on it. Because if you think about it, there's no number that you can put into that function to make it undefined. So find the domain of the following here. These are both fractions, so we might have issues in each of them. Again, we look at the top, x. We can put in anything for x and it doesn't create any problems. But on the bottom, we have x squared minus 5x plus 6, and we know that that cannot equal 0. Well, here we're going to get some more practice with our factoring, because we have to find out when does this polynomial equal 0, because we have to eliminate those values. And fortunately, this is one of our easy factoring ones. We just put an x in here, an x in here. We look at this sign, remember, and that tells us both of these signs are the same. Then we look at this one, and that tells us, since we know they're the same, they both have to be negative. So we're going to go in and go ahead and put in the negative and the negative. And then we want to find factors of 6, both negative. So negative 1, negative 6, negative 2, and negative 3. And we want to choose the set of those, the pair, that will add up to be negative 5. And so in this case, that's negative 2 and negative 3. Then our last step, again, is we need to finish this. And so what we do is we set each piece not equal to 0. And so we find out that x, we add 2 to both sides, cannot be 2. And we add 3 to both sides, and we find out that x cannot be 3. So when we write it out again in set notation, we want the set of all x's such that x is not equal to 2 and x is not equal to 3. And that gives us our domain. So it's anything except for those two numbers, 2 and 3. D is a little bit different because notice on the top here, we can't just stick anything in for x. Because if you remember back, we cannot take the square root of negative numbers. So right away for the top, we know that the thing inside the radical, this x, has to be greater than or equal to 0. And since it is just an x, we don't have to do anything more than that. It's already solved. So we know x has to be greater than or equal to 0. But we do have to deal with the bottom also. We know that the bottom of a fraction cannot be equal to 0. So we add 5 to both sides. We get x is not equal to 5. So again, we have two conditions. So we're going to have the set of all x's such that x is greater than or equal to 0 and x does not equal 5. And that gives us our solution on part D. So you do have to consider the numerator each time because there can be limitations, but most of the time when we look at these, we're going to be dealing with the denominators. The two main times that you have limitations for domain, when you have radicals, like in part D here on the top, the square root of x, and then when you have fractions. So those are the two things we want to focus on when we're thinking about domain. Okay, simplifying rational expressions. We have done this in the past, but if you look at this, when you've got a common factor on the top of a fraction and on the bottom, we know that we can cross that out and cancel those both to be 1s, and so on the top we get a over b. So that's a pretty simple property that we know. So what we want to do is use that property to help us simplify a rational expression. Again, the first thing when you have these polynomials is factor them. So if you look at this first one, the top is the difference of squares. This is x squared minus 1 squared. So we can factor this as x minus 1 and x plus 1. On the bottom, again, we have our two parentheses here. We have an x and an x. This time, this one says we have different signs. Because when you multiply these two numbers together, we're going to get a negative answer. So one of these will be positive and one will be negative. This one then, since the signs are different, this one tells us that the bigger one, or the larger one, is positive. So we want to find factors of 2, negative 2, that have a sum of 1. And there's really only one option, negative 1 and positive 2. And the question is, does that add up to 1? Yes, it does. So we're going to put negative 1 and positive 2. So now what we can do, just like our property up above here, we can look for a common factor. And if you'll notice, x minus 1 is a factor in the top, and it's a factor in the bottom. So we can cancel that to a 1 and cancel this to a 1. And so what we're left with is simply x plus 1 over x plus 2. And that is our simplified form of that rational expression. We also have a property that says when we have fractions, we multiply them, and we can just multiply straight across. So when we look at example 3, we want to multiply this, but again, the first thing we always want to try and do is factor to see if there's any canceling. So we're going to start with the top. And looking here at this top one, notice we can try and factor it with x and x. This again tells us different signs. So one positive, one negative. This one tells us the bigger one is positive. So factors of 3 where the bigger one is positive. I'm just going to do that work up here. 3 is prime, so it's just going to be negative 1 and positive 3. And that will add up to be 2, so negative 1 and positive 3 will go in there. We do the same thing on the bottom. We have x and x. This one tells us the signs are the same, so they're both positive. So plus and plus. Factors of 16, that will add up to be 8. I'm going to do that over here. They're both positive. So we got 1 and 16, 2 and 8, 4 and 4. And the ones that add up to be 8, 4 and 4. So we're going to put those in there. Then we're multiplying by, now on the top of this one, it's just a binomial. We can factor out a 3 from each of those. And when you divide that out, you have x plus 12 divided by 3 is 4. So we get that. And then on the bottom, we can't simplify anything or factor anything. We just have x minus 1. Once we've written it like this, we can when we have fractions and we're multiplying, we can cancel from top to bottom. As long as one factor's on the top and one's on the bottom, we can cancel it. So if we look at this, we can cancel x plus 4 and x plus 4. And we can also cancel x minus 1 and x minus 1. It's important to remember when you cancel these, they have to be identical. So you couldn't cancel an x minus 1 with an x plus 1. You can't cancel this x plus 3 with x plus 4. It has to be identical. It has to be totally exactly the same. So when we're all done and we write this out, we've got 3 times x plus 3 on the top, and on the bottom we just have x plus 4. Okay, your rules for dividing. Hopefully you remember these. When you are dividing a fraction, all you do is change it to multiplication, and you change that second term that you're dividing by, that second fraction, and you take the reciprocal of it. So instead of dividing by c over d, we multiply by d over c. So in this case, I'm just going to take this right here, and we're going to think about this. I'm going to abbreviate a little bit, times, and now we're going to have x squared plus 5x plus 6. That's going to be on the top. And x squared minus 3x minus 4 will be on the bottom. So we're just going to kind of get rid of this right now because we have changed this. Instead of division, we are now multiplying. So again, we factor anything we can. We've got x minus 4 on the top of the first one. Notice the second one, or the bottom, I'm sorry, is the difference of two squares. You'll have x plus 2, because 2 squared is 4, and x minus 2. So the difference of squares, again, that's that important little pattern here. If you think of a squared minus b squared, that will always factor as a plus b and a minus b. So this one could be written as x squared minus 2 squared. So keep that in mind. Then we're multiplying by, and we need to factor the top and bottom of this one. We've got an x and an x. Remember, this tells us the signs are the same. And this tells us they are both positive. So plus and plus. We need factors of 6 that will add up to be 5. So you've got 1 and 6, 2 and 3. And the ones that add up to be 5 are 2 and 3. On the bottom, we've got x and x again. This time, we know our signs are different. So one will be positive, one will be negative. The larger one is negative. So 1 and negative 4, or 2 and negative 2. I guess the only one that would possibly work there is the 1 and negative 4. So plus 1 minus 4. So as we look at this now, it's just a multiplication problem, just like example 3. X minus 4 can cancel with x minus 4. X plus 2 can cancel with x plus 2. And so that leaves us with x plus 3 on the top over x minus 2 times x plus 1. And so that's an example of division. Now multiplying and dividing are actually relatively easy. When we get to adding, as long as they have a common denominator, it's easy to add them. But sometimes we have to find a common denominator. So when you have adding fractions, remember, you need a common denominator in order to add them, and then that denominator just stays there. You don't add the denominators together. So here's what we have to do. We have to find a common denominator. And so we look at each of these denominators individually and we say, okay, I need to have an x minus 1 and I need to have an x plus 2. So my denominator is simply going to be x minus 1 times x plus 2. And we're going to take each of these fractions and give them that denominator. But once we've figured out what the denominator needs to be, we have to look at this denominator right here and say, what do I have to multiply by x minus 1 to make it into x minus 1 times x plus 2? And hopefully that's clear because we've already got x minus 1. We need to multiply by x plus 2. But whatever you do to the denominator of a fraction, you also need to do to the numerator to keep it equal. So on the top, we're going to have, we'll go ahead and distribute 3x plus 6. Then we look at the second fraction and we say, what do I have to multiply by x plus 2 to make it into x minus 1 times x plus 2? And that is, we need to multiply by x minus 1. So we're going to do that on the bottom and the top. Multiplying the bottom just gives us the denominator we need. On the top, when we distribute, we will get x squared minus x. So then we just add straight across on the top, combining like terms. So we have x squared, 3x minus x is going to be plus 2x, and then plus 6. That's the only thing left. And on the bottom, we still have x minus 1 times x plus 2. And that gives us our solution for example 5, or our answer. Okay, this one involves some factoring first. So let's go ahead and factor, and notice it's subtraction. So that what we actually want to do first then is change it to addition. So instead of subtracting, remember our property is we can add the opposite. So we'll just change that 2 to being a negative, and so now we've got 1 over, and if we factor this denominator, we see that's a difference of squares. So we're going to have x minus 1 times x plus 1. The second one, we actually don't have to factor. It's already factored, so negative 2. But we'll rewrite it. This is x plus 1 times x plus 1. Okay, so this one's a little bit different. We've got 2 factors over here on the left and 2 on the right. So initially, we've got x minus 1, we need that, and x plus 1, we need that. In the second one, we've got 2x plus 1s, so we actually need to have 2x plus 1s in our common denominator. So that will be the common denominator. So we're going to write that out a couple times for each of these fractions. So what do I have to multiply this first denominator by? We're going to multiply it by x plus 1. And we have to do that to the top and bottom of the fraction, so we have just x plus 1 times 1 on the top. In the second denominator, we have to multiply by x minus 1. And so we multiply that top and bottom. And so negative 2 times x minus 1 is negative 2x plus 2. And then we just, again, add straight across. So we get x, and negative 2x is negative x. And then 1 plus 2 is 3. And we have x minus 1 times x plus 1. And I'm just going to write it as x plus 1 squared. And that is our solution there. That's our answer. A lot of fraction stuff for you today, but hopefully most of this is review because you've worked with fractions for a long, long time. It's just that we kind of take them for granted a little bit once we start getting calculators. A compound fraction is a fraction in which both the numerator and the denominator, or maybe even both, are fractions. To simplify a complex fraction, we want to multiply by the least common multiple of all the denominators. So for example, when we look at this one, example 6, we look at our denominators, and I'm going to, just to emphasize this, write those numbers as fractions also. So notice the denominators that we have, y, 1, 1, and x. The least common multiple of all of those would be xy. So what we do is we multiply each fraction by xy. Or each piece of that. Now, when we do that, that's okay because notice what we're multiplying. We're really just multiplying the entire fraction by xy over xy. Once on the top, and then again on the bottom. But we're distributing as we do it. So notice here the y will cancel out with the y. And we have x times x is x squared. And there will be nothing on the bottom there. Here there's nothing to cancel. So it's just 1 times xy. On the bottom, there's nothing to cancel in this one, so we have xy again. And then minus this time. Here the x's will cancel, and so we get y squared. The only other thing we can do is notice on the top we can factor out an x, and we have x plus y left over. On the bottom we can factor out a y, and we'd have x minus y left over. That's not a bad idea to do just in case something might cancel, but in this case nothing does. So we just have x times x plus y over y times x minus y. Again, this one, we write them all as fractions, we get that. So our denominators are a plus h, a, and 1. Now remember, we want the least common multiple, so these things have to be multiplied. So that's going to give us a times a plus h as our least common multiple. So I'm going to multiply each of these pieces by a times a plus h. So when we do this, first one, a plus h cancels with a plus h, and we just have a. Minus a cancels with a, and we just have 1 times a plus h. Make sure you keep that in parentheses. We maybe should have switched it right away. That might make it a little easier. Instead of subtracting, we add the opposite. So let's go ahead and view it that way. We already had the a from the first one, but now negative 1, when we distribute, times a plus h is going to be negative a minus h. On the bottom, there's nothing to cancel, so we have a times h times a plus h. Okay, we do have some more simplifying here. A minus a cancels out to a 0. So now we have negative h over ah times a plus h. And since, remember, these are all multiplied together, and this is a fraction, we can cancel this h and this h, and they both become 1s. So our answer ends up being negative 1 over a times a plus h when we simplify that. Okay, again, this one's a little bit tricky because it doesn't look like a fraction, a complex fraction when we view it originally, but this is really 1 plus x squared to the 1/2 power minus x squared. And remember what this negative does? It actually means the reciprocal, so we get this. And that's a little bit tricky. You have to be careful there because it doesn't just take it to the bottom because this is not multiplication, it's a subtraction. If the ones on the top are all multiplied, you could just move it to the bottom, but in this case, it can only move it to the bottom of that individual term right here. So now the fractions that we have, we've got denominators are 1, 1, and this thing. So that's what we're going to multiply everything by. 1 plus x squared to the 1/2 power. 1 plus x squared to the 1/2 power. And 1 plus x squared to the 1/2 power. Well, notice what happens. These are the same, so when we multiply them, you simply add the exponents, and 1/2 plus 1/2 equals 1. So this just gives us 1 plus x squared minus, I'm going to keep this in parentheses for now. Notice what happens here, top and bottom, they are identical. So we can cancel them both to 1s, and they just go away. And so we have minus x squared. On the bottom, again, these are identical. That exponent is 1, so we're going to get 1 plus x squared to the 3/2 power. Notice when we add this on the top, the x squareds cancel out, so we end up with 1 over 1 plus x squared to the 3/2 power. That one's a little bit complicated because you have to use several of your properties for exponents. The idea of a negative exponent, the idea of what happens when you multiply numbers that have exponents, so you have to be really careful on a problem like that. Our last topic here is rationalizing, and when we want to rationalize a numerator or a denominator, doesn't matter which one, we multiply the top and the bottom of the fraction by the conjugate of what we're trying to rationalize, either the numerator or the denominator. So if we remember conjugates, or maybe we haven't talked about this, but a conjugate is, if we're looking at this, its conjugate is simply going to be 1 minus the square root of 2. We just take the value that's there, and whatever this sign is, we put the opposite sign in for the conjugate. Whatever that sign is in the middle, we just switch it. So we're going to multiply that on the top and the bottom of our fraction. And the reason we do that is this. On the top, that's multiplied by 1, we get 1 minus the square root of 2. On the bottom, we FOIL. 1 times 1 is 1. That will give us minus the square root of 2. This will give us plus the square root of 2. And this will give us minus the square root of 4. Now here's the convenient thing about a conjugate. These middle terms always cancel out. And that's very nice for us. Because now, notice the square root of 4 is just 2. So on the top we have 1 minus the square root of 2. On the bottom we have 1 minus 2, which is negative 1. And so that, when we actually divide that, it switches the signs. We get negative 1 plus the square root of 2. If you're not sure about that, let me give you that extra step. We break this up into that. And then we can see 1 divided by negative 1, and then negative square root of 2 divided by negative 1 gives us that. And I think this is our last example, and I hope you guys have been relatively patient. If not, hopefully you broke it up into a couple sections. But again, same process. We want to rationalize the numerator this time. So we will multiply by the square root of 4 plus h. But instead of a negative, we're going to put in plus 2. We'll do that on the top and bottom. We need to add our parentheses so we actually remember to FOIL it. So when we multiply this times this, we get 4 plus h. Now remember what happens here. This times this gives you a positive 2 times this radical. This one gives you a negative 2 times that radical. They will cancel out. Then our last one is negative 2 times 2 gives us minus 4. On the bottom we have h, and we're just going to leave this in parentheses, and I'll show you why in a second. On the top, 4 minus 4 cancels out. So now we have h over h times square root of 4 plus h plus 2. And then notice we've got h times this on the bottom, and we have an h on the top, so they can both cancel the 1's. And so we get 1 over the square root of 4 plus h plus 2. This process right here, where we rationalize the numerator, that's something we're going to use. If you ever take calculus, that's something we use a lot in calculus class. So that's something to think about there as far as where we would use that in the future. Rationalizing the denominator, that's just for standard form. We always do that. We wouldn't typically rationalize the numerator except in that calculus process. Our assignment then for this last section is given there. Remember, you will have time in class tomorrow to work on this and ask any questions. I know this was a lot to try and digest, so you may have some questions, and that's fine. Then we'll have a review day, and our test will follow that review day. So hope you guys, again, this is not a very long assignment. It's only 8 problems, so start whatever you can, and then we'll have time to work on that tomorrow.